Krista. Anybody's name I didn't call? Hey, perfect. I think we should have 20 there. One after. All right. So good afternoon. We'll quickly go over the syllabus. I'll get your questions. And we'll get started with this. We'll talk about Canvas, what I have in Canvas, the calculator, things like that. All right, so we'll start with the syllabus. I'll talk about 2 documents too. So yeah, I like to give out 3 documents on the first day. The first, just the syllabus, of course. My office hours are there, so feel free to stop by. I'm right upstairs. Take the elevator right up there. It's room 231. The textbook. All right, mine looks like this. Does it look like that at the bookstore? Some students rent it and stuff. So it does. It looks like that. And it comes with the solution manual. That solution manual is nice for support if you want to see how the author worked out the problem or his wording he used if you have to interpret like a slope or something like that. So that's good for support. You don't bring the solution manual every day. I encourage you to bring the textbook because I'll be referring to problems out of the textbook, but you don't have to. So if you didn't bring your textbook, I wouldn't be saying, John, where's your textbook? Why isn't it there? But I encourage you to bring it. But that's the textbook you'll need. We don't use my math lab in this course. But this is the textbook we're using. So if you have questions about the textbook, let me know. Yeah, cell phones, just ask you to turn them off in class or put them on the vibrate instead of silent. So appreciate that. So there's no distractions. Attendance and homework. Yeah, if you miss more than 2 classes, your grade can be lower. But I put that note there because it's usually for someone who misses 12 days. 12 days, I'll miss like 12 days in a semester, and at the end of the semester, it's like, is there any way I can pass this class? And no, your grade kept getting lowered every time after you missed the 3rd day. So that's really what that note's for. But if you missed 3 classes, one time you overslept, you work a night job, you came in and took a nap, and you just overslept, another time you were ill, 3rd time you had to pick up your mother from the hospital or something, that's fine. So I don't want you to get too stressed about that, that's why the wording I used there was like, it may be. Really geared towards the person missing the 12 days. These are the practice problems. These are really good for each one of the tests. All right, handpick these from the textbook. If you want to write on this right now, go right ahead. Do you see see that first portion there for the practice problem? That's for test 1. So test 1 is up to 3.2. If you want to write on there, just get an idea. All right, test 1 will cover that.
Up to 2.2?
Yep, up to 3.2. That'll be test 1. Chapter 1's all the definitions and words like that. Today's not the most enjoyable English. I'll try to make it fun, but it's like, you can understand terms and we'll get into a little math. It starts getting a lot better in chapter 3. So that's why there's so many sections there. You're like, yeah, the first stuff's getting the basics down. A lot of you will be familiar with that stuff too, just from your experiences taking mathematics previously or in high school. 3.4 to 4.2, that's test 2. And then 5.1 to 6.2 is test 3. 7.1 to 8.2 test 4. And then last there's a test 5 in here. We get up to 10.3 in test 5. Now after test 5, and you can look at that on the back of the syllabus. So now we get there, you can look at, this is like, I say tentative schedule because look, even something might happen to the schedule because of the weather. I mean, 8 a.m. classes this morning got lost, right? So something might happen. So I write tentative, but basically that's how we'll run. That's basically how the days will come. If we have to adjust it though, because of the day, absolutely. But after test 5, do you see there's some open days there? After test 5? That's where we're going to cover the chapter 11 material. So after test 5, we'll do, chapter 11. And what that means is the final exam's cumulative. I'll probably put like one problem on the final exam from that chapter 11 material. And I'll be able to put one problem, that's what we'll spend time on. That's fun stuff too. Like everything is geared towards something called a hypothesis testing. That's what we do at the end. So that's cool. So I don't collect these. Homework problems, but I encourage you to do them because it's really good practice. I always say that, what I'm doing on the board, the problems we're doing in class is representative of what you'll see on an exam. So I like to say that twice, so you're not getting so stressed about, problem number 102 out of the textbook. But what I do in class is representative of what's on the test, right? And these are really good to practice as well. I'll probably do a couple of these today too. All right, so take good notes. If you miss, notes, maybe ask one of your classmates to say, okay, copy your notes. Canvas. Now in Canvas, I have a lot of supportive stuff. I use the same material for my online class. And I just found something, I'll be honest, I found something 2 days ago that was really good. It was brand new. Someone made something called an e-text. So I just want to let you know it's in Canvas. And it's our author, his name is Michael Sullivan. He paired with another guy named Woodbury. And it's just something called an e-text. Well, it's there, and boy, I'll tell you, if you're going to go a week and you don't have the textbook, but you want to kind of stay on task with understanding the material, you just go in there. You'll see I put it way at the beginning of Canvas. It's an e-text. It's got the whole text. I mean, it's really well done. It's well organized. One of the best things I've ever seen. For like, oh, you want to do a practice problem. So much better than my stat lab. I'm serious. You click this, show the work, show the example. Oh, I want to click on a TID4 video to show me how to enter this in. Well designed. I mean, so it's really well. I'll be using this in my online course as well because it's great for an online student. So that's something I would encourage you. Just if you miss class, have to look at it. It's really good if you want to just kind of click through it and go through it and see some of the things they have. They have something called a chapter review. Holy cow! I was like, wow. Like the chapter review, it would give like, all right, here's some practice problems to work. And you immediately can just hit show example or show the answer. You click on it, shows it. It's like you can click on a video. If you want to take, you know, we have a lot of data in this course. You want to just take data and copy and paste it into like a Microsoft Excel sheet. Yep, boom, boom. You can do that. So it makes it real easy. It facilitates that kind of stuff. So that's cool. Getting help. Of course, email me at any time. Come to my office. I do want to say the Math Tutoring Lab in the library, room 102, has tutoring. But there's only one course where it might be like, it's statistics. You go in there and it's someone who knows everything from Algebra 1 to differential equations and calculus. And they're like, oh, I'm not really good with stats. So if that happens, I know. They're always trying to get more stat tutors in there. So, hey, do well in this class, and then, hey, eventually you can become the stat tutor over there because they usually need some. Yeah, and I just, for disruptive behaviors, you just don't talk in class. Like, sometimes you're not doing it on purpose, you're just talking with your neighbor about something, be distracting others, but I'll take care of that as well. You know, make sure to say something to that person, so just, you know, not in a negative way, just to say, hey, people can't hear me, so please don't talk here in class. Hey, any questions for me? Awesome. Hey, is this your last class of the day? I'm just curious. Show of hands. You see how many there are? Hey, have you ever seen a Tuesday, Thursday at 1:45 out in the parking lot? Oh, it gets crazy. All right, so it gets a little crazy. So what I always do is probably about 5 of. I will usually end it right then, and then people can come up and ask me any questions they want or work around stuff. Does that sound good? That little 5 minutes can sometimes save the student 20 minutes sitting in the what? In the parking lot. Okay, so it works well. I did it last semester, it was fine. Hey, I'll get started, and feel free to ask me those questions at the end. We start in 1.1. This is elementary statistics. All right. Elementary statistics. We'll start with, how about a definition? Yeah, what is statistics? And we'll keep it short. I know you can read the text. You can read the definition out of the textbook, right? Well then, how about this? For statistics, or a statistic, we'll just say, well, it's a numerical summary. How about that? It's a numerical summary. Statistics is a numerical summary. That's the baseball player's batting average. Okay, it's a numerical summary. That was Tom Brady's passer rating. It's a numerical summary. It's numerical, right? It's summarizing something. It's giving a summary of what they did. All right, that's about his passer performance, right? That's his batting average. So statistics is a numerical summary. You read in the book, you might say, well, it's a numerical summary of a sample. So let's go over these two words right away. Population, sample. Sample is a subset of the population. Yeah, sample is a subset of the population. So let's give some examples so we make sense of that. Let's say that we're talking about for a population. I'm defining the population to be, in this particular situation, all AACC students. So you know what a sample could be?
This class.
This class. You beat me to it. That was good. This class. That would be a sample. It's a subset of the what? Gigantic population. We're talking about all AACC students. All right. If we define that as a population, sometimes they call it a target population because you're trying to target them with a question. You know, we want to see what the students think. All right. Well, they go out and we take a sample. That's what we do in statistics. We take a sample. We hope it's representative of the population, but it's a subset. This would be, you know, one sample of that. So a sample is a subset of population. But a lot of times, when a population can be like, well, all college students in the United States. You're like, oh my gosh, all college students in the United States. Well, then a sample could be still this classroom true, but it also could be this entire college. Who said that? All the students in the college. So you see, sometimes population, the actual number, the value, it represents how many people in it. It could be in the millions, can't it? I mean, sometimes it reaches millions and millions of people. This could be huge. Samples are when we keep them quite small. Not too small like 4, but sometimes they're 1,000, sometimes they're 500, sometimes they're 60, but it's a subset. So the first problem we're going to do on the book is we're going to read something, and we're going to have to define, all right, exactly what is the population they're trying to target, and then we're going to mention the sample. We're going to write it out, okay? So we're going to name the population in this problem, and then we're going to name the sample. All right, that's the first thing we'll do. I'll do the long line here. We're going to name the population, we're going to name the sample. I'm in section 1.1. I'm on page 12 of our textbook. And I'm going to do number 39. I'll read this to you if you have your textbook. The Gallup organization contacts 1,028 teenagers who are 13 to 17 years of age, live in the United States, and they ask them whether or not they've been prescribed medications for any mental disorders such as depression or anxiety. I'll reread that too. You and I are going to talk about what's the target population in the sample. Again, the Gallup organization contacts 1,028 teenagers who are 13 to 17 years of age, live in the United States, and asks whether or not they've been prescribed medication for any mental disorders such as depression or anxiety. Okay, so we're going to start out with the population. I heard a number in there. Do you hear that number?
1028.
Yeah, 1028, 1028. That is not the population. That's not the population. We don't know that number. A lot of times you don't. Sometimes it changes every hour, every minute. It's just changing. So how about when we start out this phrase, when we define or talk about the population, you want to start with the word all? I'll start with all. All. All, what can I say next? Teenagers, I like that. This is about teenagers. All right, all teenagers. This is who they're trying to target with this question here from Gallup. All teenagers. Ooh, brilliant. It was a specific age, right?
Mm-hmm.
All teenagers, 13, 17 years of age. Now, was this like in the world, or was it specific area? Like, was it Maryland or Ohio?
United States.
And was it just in U.S. or were they doing something in the U.S.?
Living in the United States.
That. So this is what I'm going to hit on. They said what? Living in the United States, right? So I actually have to write that. It wasn't like I'm in the United States, like someone's coming from Brazil and they're just going to come over, they're going to be here for you. They actually live in the United States, so I'm going to put that. I have to put that word, living in the U.S. All right. I think we're done there. That's the population. All teenagers, 13 to 17 years of age, living in the United States. I guess we don't even have to put the word teenager anymore, right? If you're 13 to 17, aren't you already a teenager? So if you want to just say all 13 to 17-year-olds live in the United States. Excellent. Now then they say something about medications and stuff. We don't put that here. That's the question they're going to ask them. They're going to reach everyone. We want to reach everyone. At least we want to target them with this question. And then we'll ask that. Some will say yes, some will say no. Now the sample, will you remember this even on the test? We got to put identical, everything we see, because this is a subset of this, right? I see the word teenagers, I want to write teenagers. I see 13 is, I'm going to write 13 to 17 years of age. I mean, identical, because this is a subset of this. Living where? Living in the, I have to put it because this is the subset of this. This is the sample. This is a subset of the population. Now, guess what I can put here? I can put something specific here. Don't we know a number?
1028.
That number that was read in the problem, that 1,028, remember that? They go, the Gallup organization contacts 1,028 teenagers. I'm going to put that number right there. All right, so 1,028, that's the sample size. So there you go. I wouldn't give this. Be comfortable with something like that, you know, during an exam. Awesome. Hey, I'm going to start introducing you to some symbols. We get a lot of symbols in here. Did you see that formula sheet I handed out? It was like, oh my gosh, you go, I have to memorize all these? No, these formulas get attached to all the tests. Okay? I won't put this whole two-sided sheet on your first test because for the first test you only need 2 of these. A lot of you have memorized anyways, but I'll put them on here. But there will be, throughout the course, there's going to be about 3 formulas that aren't on this sheet. So I'll make sure you know that. So you go, oh, you gotta have to remember these, okay? They're easy ones too. So I'll point those out as we get through the course, yes.
Does that go into any type of subsample?
No, we can just stop right there. No, that's it. I got you though, if you subsample that. We're gonna talk about sampling though, but you might even go from there and go, all right, what's the subsample of that?
Yeah,
no, we'll just stop there, yeah.
Because of the medications and like the people that are classified
Oh, I got you.
for anxiety.
After this, maybe someone might even look in and do like some kind of experiment or something like that. And you're right, it never stops here. After this, they may go somewhere, but that's what's neat. We don't even write that down because that was the question they asked them. Some people would say yes to that question, right? Some would say no. And you always wonder, some people might not even tell the truth, correct? Yeah, sometimes you get biased. You get biased in these studies, absolutely. Cool. Everyone okay with this? Now I'm going to put some letters down. What's the symbol that's going to represent the size of the sample? Lowercase n. So I'm going to put this. So throughout the entire stats course, you're like, what does lowercase n always represent? The sample size. It's a numerical value. Lowercase n is the sample size. That n, sample size. So n equals 1,028. Everyone agree? Now this is good. This is appropriate. Guess what letter we're going to use to represent the size of the population, which we don't know? It's got to be a lot. Do you agree it's more than 1 million? Mm-hmm. And when you agree there's probably more than 1 million 13 to 17-year-olds living in the United States? Yeah. There's a total of 325 million people live in the United States. Maybe a little bit more than that. So between 13 and 17 years old, you're like, yeah, it's more than 1 million. Well, we don't know and it's changing, but I want to let you know what symbol we use. Capital N. Very good. I heard it. Capital N. So that's size of population. This is size of sample. Here, I'll write them right next to it. That guy. What? And this guy. Subset of the big N, right? But if you're like, what's n equal to? Well, you could do this and maybe in parentheses just say what? In this case, millions? A lot. There's a lot. And it's changing, isn't it? Someone who was 12 just turned 13 5 minutes ago in the United States, right? Someone who was 17 just turned 18, you know, 30 seconds ago, right? Isn't it always changing? But it's big. It's big. We could estimate it. Awesome. Hey, can I erase this? Hey, the next word we'll go over. I know we got to get all these terms down first day, but these terms are important. You can read. I won't go over every term, but I will highlight the important ones. You can hear all over and over and over. And you can read chapter, section 1.1 because it's really good. Or use that e-text. Just click through that, and when they got a thing with the vocabulary, you just click on the little vocabulary word and it gives you a definition. It is a really good setup. So if you want to get some of these terms down, I encourage you to use that when it's in Canvas. Variable. Well, a variable is just a characteristic. We have variables in statistics, but it's just a characteristic. There's two types we're going to see. Discrete. A discrete variable. And a continuous variable. A discrete variable and a continuous variable. These characteristics. There's a discrete variable and there's a continuous variable. Professor Messer, you should read the definition out of the book. I know you all can read that, right? You're like, I don't need you. I don't have to pop up a PowerPoint slide and you all copy it down. You can read it out of the book or go to that e-text, really. I'm going to come up with one word for each of these to help you understand this. You remember this throughout the whole course. How about discrete? Countable. How about that? When we look at some variable, I want you to think about it and go, man, is that something I can count? Is it countable? Continuous. I want you to think, is that measurable? Is that something I can measure? Is it measurable or is it countable?
What's the difference?
And we'll see some in here. Now, mathematically, Art, this, in terms of countable, I want you to think this just like a bunch of integers. 1, 2, 3, 4. Where these, a continuous variable, something that could be like 1.369258 and then 2.895362. Have you ever heard pi before? You know, 3.1415926. I mean, these kind of numbers where it's just infinite amount of possibilities. And something's out there. But this, I want you to think what? You can take out your fingers and go 1, and 2, and 3, and 4, and countable. So I'm going to read some out of the book. Everyone, page, hold up. I'm going to go back to page 11 and 12. So you can write down, it kind of goes from 11 to 12. I'm going to think about 4 of these. And I bet you go 4 for 4. I'm going to read something to you. I want you to identify that variable. Is it a continuous variable or a discrete variable? Oh, if you want, just feel free to write D or C. Yeah, if you just want to abbreviate. Is it discrete or is it continuous? Here's the first one. This is number 23 on page 11. Discrete variable or continuous variable?
Discrete.
Goals scored in a season by a soccer player. What do y'all think? Goals scored in a season by a soccer player. Listen how loud that is. They know. Can we count that? She scored 2 goals. 1, 2. He scored 3 goals. She scored 0 goals. We can count that, right? So I'll put discrete. Everyone, very good. Number 24. If you think you know it, raise your hand. The volume of water lost each day through a leaky faucet. Oh, the volume of water lost each day through a leaky faucet.
Continuous.
It's continuous. Very good. It's measurable, right? 3.2964 ounces came out of that faucet. Oh my gosh, this faucet's been going for a while. It's about 5.2938 gallons came out of that faucet, right? We don't count that measurable. So continuous. Very good. All right. 2 more. I think you're an expert. Number 26, just the number of trees randomly selected in a certain acre of a national park.
That's
What do you all think? What would you say, Art?
discrete.
Discrete. Can we count that, everyone? The number of trees. It might take forever. It might take me a few hours, but I can do it. You know, and I'm looking out this window. I'm like, 1 tree, 2 trees, 3 trees, 4 trees, 5 trees. We can count those trees, right? So I'm going to put count. That's discrete. That was number 26. Hey, I'll do one more. Let me flip to the next page. Okay, everyone. If you think you know it, the temperature on a randomly selected day in Memphis, Tennessee. Tia. It's continuous. Tia, excellent. The temperature on a randomly selected day, we don't count that, right? That's something we measure. Right now, it's 31.62 degrees out there Fahrenheit, right? We say it's 31 degrees Fahrenheit, but it's really something like what? It's probably 31.62581 degrees Fahrenheit. It's something we measure. So I'm going to put for number 20, it was number 27, yeah, continuous variable. It's continuous, we measure it. Everyone okay with this? These two types of variables we encounter in statistics. And when we do, we attack them in different ways, which is kind of neat. You're like, oh, that's a discrete variable. That's a continuous variable. Awesome. All right. Hey, I'm going to erase this. We're now going to move into section 1.2. There's a lot of other terms in that section. I will bring them up as we go through the course. But yeah, I would bore you to death if I sat here and let's do the next definition. Let's do it. You can click on those in the e-text. They'll come up in this course. I will say this. The whole idea of this course is we do something called inferential statistics. And you go, what's inferential statistics? That's the idea. We get a small sample, it's representative of the population, and then we make inferences on what's going on in the population. We go to kind of estimate what's going on in the population. Inferential stats. 1.2. Yeah, I encourage you to read this section, but we're going to highlight one thing in here. This is observational studies versus experiments. Well, what we'll do is we're going to highlight like one key, I guess, thing that applies to one of these. One key thing. And then, and I bet you someone in this class knows the answer. More than one. And then after, all right, let's just talk about a good experiment. You know, with some characteristics, details of a good experiment. So observational studies, experiment. One of these two, when you perform them, you can justify a cause-effect relationship. All right? And a lot of people already know. Well, let's say this again. In one of these two, if you did, I'm going to do an observational study, or I'm going to go do an experiment. Well, in one of these two, you can justify this type of cause-effect relationship. So after the whole thing's kind of completed, you know, may have evidence to say that, you know, this may lead to this. I bet you someone knows. Which one is it? Oh, what do you think? Experiment. So I'm going to put it right here. In an experiment, you can actually justify cause-effect relationship. You know, I'm thinking, well, what's an example of one observational study? Yeah, I had a colleague of mine. They went around high schools and around the community, Anne Arundel County, and they observed. They counted on how many times they used a calculator, how many times they used a cell phone, how many times they used a bathroom, how many times they raised, you know, observational study and all this stuff, compared it. But in the end, could you say after that whole observational study, can they come up with this conclusion? Okay, using calculators makes you better at performing mathematics. Causes you to be better at mathematics, right? You're like, no. But we can talk about a good experiment. So for this experiment, I'm going to give you an example that happened in real life. I'm going to go to 1954, the Jonas-Salk experiment. Just for an example. No, on a test I won't go, what happened in 1954 in the Salk experience? It's a good example of a good experiment. All right, had all the necessary conditions. What was going on? Everyone, a lot of children were either being paralyzed or dying, actually. All right, from polio. Yeah, they were. This is back in 1950, early 50s. And it was affecting a lot of children. All right, so either a lot of them were being paralyzed, but some were dying, right? So Jonas-Salk, you know, I think maybe I have a vaccine for this. I'm going to conduct an experiment. So the first thing, he puts them into two groups, right? Treatment group and the control group. So we could say this. The first thing is, it's this experiment comparative, huh? It's comparative. The idea, we're going to compare this group to this group. Control group, treatment group. I bet you know. What do you think the children got in the control group? A placebo, I heard it, right? You're like, what's a placebo? They didn't get the real treatment, right? Maybe they thought they did. They got a placebo. You're like, what's that? That's like sugar water or sugar pill or something like that. You're getting something. You're not getting the treatment. Or it's the drug, not getting the drug. they're getting the real stuff, right?
Mhm.
And now, who was placed in this? Well, anybody who was diagnosed with polio was in this study. Okay, well, how are they placed in these two groups? They were placed randomly. Ah, so that's nice. Randomly. They were randomly placed in here or here. And I know you're curious, like, well, how do you do that? How do you do things right? That's what we're going to learn in this course. We're going to learn in the next section, actually. It's coming up next. How do you do that? How do you put them in different groups randomly? How is that done? But it was done randomly. So it wasn't like, oh, we'll just take A through M, last name, put them here, and the rest we'll put over here, right? It was actually done randomly. And this is the third condition. That makes it actually a really good experiment. It was a double-blind experiment. It was double-blind, and I bet you someone in here knows about that. What's a double-blind experiment? Tell everyone.
Neither the person who's giving it or the person who is administering it like knows what it is.
Yeah. So in here, think of that child. Say they were 9 years old. They're going in, and they're getting a shot, right? They're getting a shot in this thing. They don't know if they're getting what? The real thing or a placebo. And they're probably going in there saying, I'm just getting this. That's what they're thinking, right? Second thing is, he goes, even the doctor who is checking the eyes and checking the ears and checking the nose and doing all this, even that doctor didn't know if they were administering what? The real thing in terms of this. So, very good. Those are the best experiments when it's double blind. Someone outside was in control to make sure, handle that so the doctor would have had no idea what they were giving them. Well, anyways, in the end, everyone, all these, if you want to look up these stats, they're available online. This is the one I remember. In this group, 4 died, and here 0 died. But, eventually we would say, ooh, we have a vaccine, right, to cure polio. Now, it's basically been eradicated, right, polio, but can you still find conditions of polio on the globe? Mm-hmm. Yeah, you can still, you can even look at it just in some small cases where it still occurs. You're like, man, we gotta give them the vaccine, right? Well, maybe someone might be like, no, we can't take that. We don't take that. Or it's against my religion or something like that. But yeah, there's still, you can find some cases of polio on here. So, but those are the good qualities of that. So hey, before I race, observational study or experiment, which one can you justify this cause-effect relationship? Experiment. Experiment. Yeah. It's like sometimes you might read a label somewhere, and on the label it says, this may lead to this, like this here. It's on a cigarette package. It says, this smoking may lead to cancer, may cause cancer. And you're like, how were they able to put that there? Well, someone did an experiment. They didn't just do an observational study, people were coughing, right? An experiment was actually done. All right, 1.3. Hey, these first 3 sections, go quick. I'm sure you'll read it. It's some good information. At least click through the e-text. You might find that more enjoyable than just reading a book. It's actually fun. The slides zip through. It's quick, too. Oh, I will mention this. Gosh, I almost forgot. So I found out last night, this e-text, remember I said it's brand new? When we contacted them, we're like, man, some of these videos aren't working. And they said to use Firefox browser rather than the Google Chrome. So I've been using Google Chrome browser, probably in the past 3 years, just use it. It seems to be great for everything. But this is the first time I found out that actually, to get some of those videos to work in the e-text, it's better to use the Firefox browser. Right? And I opened up with the Firefox browser and the videos work. I don't want to point that out. This is titled Simple Random Sampling. All right, Simple Random Sampling. All right. Simple random sample. Finally, we're getting to some numbers. So we're going to talk about how to perform simple random sampling. Like in that last example, how do you do things randomly? Well, the procedure is called simple random sampling. And to better understand this, we always use an example. So I'll use an example. Let's say, and when I think in July, what went into effect last year was this whole smoking policy, no smoking now on campus. And perhaps I just want to go out and get a feel from the students what they think. So I'm going to target all the students at AECC with this question. I'm going to ask them, yes or no, do you agree with the smoking policy? That took place July 1st, 2015 on the campus of AACC. All right, so I'm going to ask them that. Well, simple random sampling, step one is I need a list of every student that attends AACC. And secondly, everyone gets assigned a number. That's step one. So I'll let you all write that down. That's key. So if I'm going to do simple random sampling, and you heard me like I'm going to go out and I'm going to ask some people this question, what's your think? Yes or no? Agree, disagree with that policy? Well, step one is, if I'm doing simple random sampling, I need a list of all names of all students who attend what? AACC. Every name. Second thing is, they all get assigned a what? Number. Now, does it have to be alphabetical? No, but you could make it. You can make it alphabetical. Doesn't have to be, though. So you're like, all right, student number 1 is, maybe like Abel, Dan. And student number 2, Anderson. Betty. There's probably 2 Andersons, right? Anderson. Carl. You go all the way down the list. And let's say there's 15,000 students. Oh, maybe student number, assigned number 15,000 was Zweibel. Frank. All right. There they are. Everyone got assigned a number. We use a spreadsheet to do this, right? But that's what's key. I'm doing simple random sampling. See, everyone gets a chance. Everyone gets a chance. Even that online student who lives in Germany. They're like, why do they care about the smoke about? They're not even here. Well, part of the population. Maybe they're going to be taking a class here next semester. You never know, right? Maybe they're coming back. So everyone's going to get a chance. Now, step 2 is, there's a couple ways we can approach step 2. First, we can go use a random number table. And I'll show you what a random number table is. Now, we're going to have to generate a sample size. That would be predetermined. How about, for our example, everyone, I'm going to get 100 students. So in my example, for this problem, 15,000 students in the population, I'm going to get a sample size of 100. And I'm working with a few unit class, and that's what we all agreed on. Let's get 100. All right, so we're going to get 100 students. We're going to use a random number table. So, if you have your textbook, go to page 25. If you don't, I'll just walk around and hold this up and go look at it. Or write down page 25. Or everyone, feel free to Google random number table, and you'll just get web pages like this. It's just a bunch of numbers in it. It's just a bunch of numbers. It's a random number table. Why are there columns between them? To make it easier to read. If they jammed those all together, our eyes are like, whoa. So they break them up in columns so they're easy to read. They could have broke them up into columns where they just went by 4 or by 3 or something. Someone here just chose to break them into columns and go 5 numbers and then put a column, 5 more and stuff. You could read this left to right, up, down, up, doesn't matter. But from here, we're going to generate our sample. Sound good? Now, I guess I could start in the top left corner, but I can make it more random. Maybe I'll pull out a coin out of my pocket. I pull it up and I flip it up in the air when the coin falls on the page, and wherever it falls on the page, that's where I'm going to start. Okay? So let's say I do that. The coin falls in row 4, and that left number all the way in the left column. If you don't have your book, I'm going to read it to you. Here it is. So here's a number. I'm going to write it down. This is going to be the first student in my sample. It's student number 27575. Okay. And I'm going to look them up. That's going to be the first student in my sample. Cool? There's only one problem, isn't there? Everyone, where's student number 27575? What's the problem? What's the dilemma? Does anyone see it? Yeah, that's the number I got right there. I looked up column 4 is the first number, 27575. The problem is I don't have a student with what? Number 27575. You go, well, what do? I just cross it out. I go to the next number. That's all. Now I can work left to right, or I'll go up and down, right? And everyone, if these numbers were what, 6 digits long or something, or only I would go by 3s or by 6s. But in this case, I'm always going by 5 digits long, right? Because it can get up to. Do you agree? All the numbers can get up to 5 digits long. You can even think of that one as a look 0, 0, 0. You can think of it like that. If I looked in this table and I saw the number that popped up was 00001, I'm calling Dan Abel, right? By the way, that's how we still get in touch with them. Maybe they got a cell phone number. You call them on the cell phone. It's still the way to get in touch with people. All right. Landlines too. Those are going away, but there's still some people still have the landline phone. All right, I'm going to go left to right, everyone. Here's like 275. The next number is 04429. Now, is that in the list? You bet. So, everyone, student number 04429. Edwards. Donna Edwards. I'm calling Donna Edwards, right? I'm calling Donna Edwards. Get in touch when I ask this question. I got one, right? Now, I've got 99 more people to find, don't I? What do? I just keep going. I just continue the process. If I get numbers that don't work, I just do what? And you're probably going to get a lot of cross-outs, aren't you? That's what I mean. Get used to that if you use the number table. Now, the good news is there is another way. So I'm going to put over. Because it is the year 2016, and we do have technology, right? So you can also use a random number generator. You can use a random number generator. A random number generator. That's a lot more fun. And when you can Google that too, you get web pages, random number generator. Give me a random number and you put in 1, and you have another box, between 1 and a million. You put 1 million, it's going to generate a random number or multiple random numbers between those. I do want to point out that this is not truly random. They call it pseudo-random. You go, why? Because it's generated by somebody's math program. Someone wrote a program to make the numbers kind of what? Bounce around, right? But somehow it's just going through some program, so it's not truly random. But I'll tell you this, for our circumstances, whatever we're doing, it's random enough. Does that make sense? Does it? Yeah, it's random enough. Heck, it's easy. I just punch the numbers in, it's going to put all these random numbers. It's random enough. So with your TI-83 and 84, does everyone have one? If you don't have a TI-83 84, I encourage you to get one. Some are newer models. TI-83 is fine. The new TI-84s look really fancy and nice. So when we go through things, they have a different setup on the account, and I'll let you know about that. So I'm going to use the random number generator right off this checklist. I'll get mine out. If any questions, I got videos in Canvas. Lots of TI-83 84 videos if you're curious about doing this stuff. If someone in this course prefers to use Microsoft Excel, let me know. That would only require you to probably have to bring in your laptop every day. Hey, maybe you like that. Maybe your laptop and you prefer to use that. So that goes for anybody. If there's a student in here who prefers Microsoft Excel over using this thing, because you love Excel, that's totally fine. This will do it all. So and what I'm going to do is clear screen. Can everyone see that? Should I hit the switch? I'll get your view. What do you think? Hit the switch? I'm going to hit the switch, all right? Just don't want to put you to sleep. All right. That's a little show off. All right, I'm going to go to the math button. Ooh. Math. Is that showing up? I hope so. Dark enough. I bet you can make it a little darker. That's a lot better. All right, so I go to the math button. Then I use the right arrow. And I'm arrow to the right to PRB. PRB stands for probability. Get that objectified. It's number 5. Everyone see number 5? I'm going to go down to number 5 there. Whoops. Sorry about that. Let me get back to PRB. I'm going to go back to number 5. It says randint. I hit enter. I need a random integer between 1 and what? 15,000? Mm-hmm. So I hit 1. I hit the comma. It's above 7. So if you're like, where's the comma button? It's sitting right above 7. And I put 15,000. And I just hit enter. Oh, and then I hit enter again. And then I hit enter again. And I do this 100 times until I get my what? All the people over here, and I give them phone calls, right? Mm-hmm. Hey, don't you agree some people don't answer the phone? I don't. If I don't recognize a phone number, I am not answering. I am not picking up. So they try again. They try again. You know, try that. Maybe they go after like 5 times. Maybe they might have to move to someone else. That's exactly what happens. But we'll get a random sample of 100 people in this case. So you keep hitting. By the way, sometimes you can get a repeat number. You can get a repeat number in here. And so if that happens, just cross it out. It's a lot more fun though this way, right? And there's websites for this too. You go, is that truly random? Nah, it's pseudo-random because these computer programs, like this one, it has a seed. Like a seed of a tree. You had a seed and the tree did what? Went like this. These programs started with some seed and off that number it started doing its what? Bounce around. Boop, 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 boop. So if you're like, can I change a seed? Yep, there's directions in the book how to change a seed. Do you need to be concerned with changing a seed? Not for my course. You know, I know this isn't a computer programming course, but if you use this a lot, I would be like, hey, you might want to change your seed a little bit, right? Like at the end of this course, I'm going to give everyone a chance to be exempt from the final. I'll let you play a little Keno game, and I'll probably use this to generate my numbers. Well then, you know what I'm going to do? I'm probably going to change my seed. Because if I don't, someone knows my seed, they can pretty much get an idea what numbers might pop up.
So we keep doing it like 15,000 times? Or just
But you wouldn't do it 15,000 times, because for your sample, remember we have 15,000 population, but we only wanted to generate a sample of 100.
Oh, okay.
So you're going to do that 100 times. Hey, it'd be a lot quicker than this way, huh? With the cross out and cross out. Random enough. I just wanted to get, you know, I wanted to get 100 of these randomly. It would work. True? And sometimes you get a repeat number. All right, cross it out. You know, maybe this one comes up twice. Like, cross it out, go to another one. And you'll eventually what? Just get, there's websites you can get it to print out 100 right away. 100 at once. But I can just keep it in there. Oh, call student number 2622. Cool. Hey, so you could change the seed on this thing, but that involves, I'll go back to that button. Number one, everyone see this number one thing? That's, you won't have to hit that unless you wanted to change your seed. You know, you want to use this a lot for something else, or doing something. You could change the seed of that, but not important here, right? If anybody wants to change it, the directions in the book, or you can ask me. I don't want to make you go through this. We're like, this isn't a computer programming course, right? It's random up. Plus, there's some good websites on there. All right, hey, real quick for the test. For that problem, what do I like to do? Me, personally, I actually like to, make that question a multiple choice question. Right here. Because, think about it, everyone, maybe I designed a test. Couldn't someone just walk in, they missed the first day of class, just start writing a bunch of numbers down? And make them up, right? So I like to assess, does the student really understand simple random sampling? So I'm going to erase this. I'm going to make up a little multiple choice question here, everyone. You got to tell me which one's the proper one, all right? All right. Which one of these is simple random sampling? I mean, you know, like, what do you call it? The food court, the cafeteria over here in the Sun Building? Maybe I'm going to ask a question about that. So I'm going to ask a question to AACC students this time. So once again, AACC students will be my population. And I think I'm going to get 60 people in this sample. I think I'm just going to ask them, you know, yes or no, do you use the food court or the cafeteria over here in the Sun Building, where they have food and lunch and stuff like that. I won't consider the subway that's over there in that building, just that food court. All right. So, is this simple random sampling? Letter A. I go to the front door of that cafeteria, and the first 60 people walk through, I ask them that question. Is that simple random sampling? No way. Do you agree? Was that even close? No way. The idea of simple random sampling, everyone gets a chance, right? Even that student in Germany gets a chance to be in a sample. The person in Germany is not going to be walking through that door, are they? Right. Exactly. Or what about the student who takes all their classes at Arundel Mills in Glen Burnie campus? Are they walking through that door? No. See? So that's the idea. So that's not even close to simple random sampling. By the way, there is a name for that. I'll put it way over here. That's called convenience sampling. It's called convenience sampling. They mentioned that in 1.4. It's not hard to do, huh? It'd be done pretty quickly, but it's not very scientific, is it? Convenience sampling. All right, how about this one? Letter B. Letter B. I go to the library, front door of the library. Every 10th person, I ask the question. And I will continue this until I get to 60 students. Every 10th person, I ask them a question, I sit there and count as people walk around. Hey, how you doing? Right? And I'm like, number 10, hey, I have a question for you. Is that simple random sampling?
No.
No. It's not even close, is it? Again, you're thinking about that student in Germany. Like, they wouldn't be walking through that door. That, by the way, is called systematic. It was systematic sampling. Like assist, I was like, every 10th. Again, not nearly scientific. This is way more. This is the way to go. This idea of simple random sampling, everyone gets a shot. So how about letter C? Well, first, everyone, step one, I go to the president. I talk to the president, I have a meeting with her, and I get a list of every student that goes to AACC. Every student, and they're all assigned a number. All right? If they aren't already assigned a number, I assign a number. So I get a list of everyone who goes to AACC, I assign them all numbers, and then, after that, I use a random number table or a random number generator to generate 60 random numbers so that I can contact those people. Is that it?
Mm-hmm.
Ding, 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 ding. You like that? Simple instance. So that's how actually I like to assess it. All right. I like to make sure I know you could do it. There's practice problems on how you do it. They got one problem with the 50 states in the book. It's fun to do, but you know the process. All right. Hey, I'm gonna go to 1.4. What's 1.4? It's called other sampling techniques. You and I are going to focus on two. Other sampling methods. You and I will focus on two of them, okay? Two of them. Those two? But they're in the section. And when I put them way over here to the side, right? Let me put a wall over here. All right, let's keep those over there. There we go. Convenience. They're in that section. In other words, I'm going to talk about stratified sampling. Stratified sampling. And there's another one called cluster sampling. They both involve groups. How about that? Somehow they involve groups. I know. They both involve groups. Stratified sampling and cluster sampling. Hey, more importantly, both of these methods use simple random sampling in some capacity. So I want you to know that. Both of these methods, in some way, in some manner, use that simple random sampling method we just talked about, okay? Well, what goes on in stratified sampling? Well, that's where you can break up like a certain population into groups. But they're strata. They call them strata, S-T-R-A-T-A. And you go to strata. Those are homogeneous groups. So you break them up into strata. Which are these homogeneous groups? What do you mean by that? I'm saying each one of the groups have something in common. Each group, something. And there's something about that group that makes them all basically kind of, have something in common. So here's an example. And when I go over to a high school down the road here, it's in Severna Park. Let's say there's 2,000 students in the high school. Let's say there's 500 freshmen. There's 500 sophomores. Let's say there's 500 juniors. And let's say there's 500 seniors for simplicity. And the whole school has a total of what?
2,000.
2,000 students. And in this case, I'm saying the 2,000 students, that's my population. But I'm going to go over there and ask them a question, are you considering going to AACC next year? I'm asking that question, yes or no. Take a little poll, true? But I want to use stratified sampling. Right? See, some of you might go, yeah, just ask the seniors that. They're the oldest. Ask them. But I mean, is it possible, do you agree when a junior could come here? Mm-hmm. Yeah, see, they know this. They're like, they got these jumpstart programs and all this stuff, yeah. So it's possible. So let's say I decided to use stratified sampling. So I'm going to get a sample size of 80, let's say in this problem. So I could get 20 of the 500 freshmen. I could get 20 of the 500 sophomores. I could get 20 of the 500 juniors. I get 20 of the 500 seniors. This is called stratified sampling. Homogeneous groups. What makes all these the same? Well, they're all what?
Freshmen.
They're all freshmen. What makes all of them have something in common? They're all sophomores. I just broke them into groups. And I took like 20 from this, 20 from that, 20 from that, 20 from that. That's because it's just something I want to do. You might say, is that better? Is that better than before? No, it's not better. We can't say it's better, but it was my what? Intention. This is what I wanted. I wanted to make sure I had representation from all the 4 classes. Okay? Now, I bet someone knows this. How am I going to generate the 20 random names from the 500 random names? I mean, from the 500 names at that school.
From the
What technique?
random number generator.
I mean, exactly, but what technique? What's the method called?
Simple.
Simple random sampling. So does that make sense? So exactly, very good. And he goes, you can use a random number generator if you want to do this. But I will do simple random sampling to generate my 20 random names from this, right? All the 500 get a number. Everyone's assigned a number, and then I go to the random number generator or random number table. Does that make sense?
Mm-hmm.
So this is called stratified sampling. And I can't say, oh, is this better than before? Is it better? But you know, even a Census Bureau might use stratified sampling at some point. But it is a method. So, but it did utilize simple random sampling. All right, what's cluster sampling? I'm going to give you an example of this. Cluster sampling. Let's just say, I'm looking at airlines, everyone. I want to ask the passengers a question. And let's say it's specific. It's, how about Southwest Airlines? I know. And Southwest Airlines. I know the one flight I know always goes from BWI to Fort Lauderdale. So that's the one I'm going to kind of hit on. BWI to Fort Lauderdale. FTL. There's a bunch of flights that go every day. And vice versa. They go from Fort Lauderdale to BWI. A lot of flights. Southwest is running there all the time, right? Start out early in the morning, go late at night. And let's just say that there's 80 flights throughout the entire week. Okay? Let's just say, so there's 80 flights out of the entire group, entire week. What do I want to ask them? Well, I guess for the past year, let's say they've been serving pretzels and peanuts. So that's my question. I'm going to ask them, do you prefer pretzels or peanuts? All right, now, but everyone, I'm not going to sit at that airport 7 days a week, falling asleep, waiting for these airlines to come up, people come up to ask all these questions, So what I'm going to do, I'm going to get a random sample. I'm going to use cluster sampling. So I'm just going to hit 4 flights. I'm just going to pick 4 flights. I'll do it randomly from the 80. But here's the key. All passengers on all those 4 flights will get my question. That's the list. So if you're like, these seem kind of the same with the groups. When there's 4 groups from all these groups? Yep. Chose it randomly. You're like, well, these were groups. But in this case, see this group right here? I only got 20 from that group. When I picked this cluster group, these 4 clusters, every passenger gets my question. Pretzels, peanuts, right? I'll just stand at that door and ask them, pretzels, peanuts, pretzels, peanuts, pretzels, peanuts. All of them get the question. Even that word might give it away. If you're reading through this section, you're like, I don't know if that's stratified or cluster. Stratified, they'd have to have something in common, right, in these groups. How do I know everyone in this flight's in common, right? I don't know that, unless it's like the Ravens football team, and they were just on all flight together, and they were going on vacation, you know, a bunch of them going together, but yeah, and they took up the entire flight. No, it's just 4 groups, but all of them get the question. So I'm going to read a couple out of the book, and I want to see if you can tell me, is it cluster or is it stratified? All right, this is a 1.4. Let's see how good you are. Hey, testing purposes, I actually like to do this. I don't do a lot of multiple choice problems, but in this case, it's appropriate to just do a multiple choice question. Where I state it like the book does, and I put letter A. Is it convenience sampling? Or is it systematic sampling? Or is it just simple random sampling and nothing else? Or is it stratified? Or is it cluster sampling? This is on page 37. it's in 1.4. I am going to pick problem number 14. It's an even number. Hey, that e-text has problems like this. Practice. Cool. Also, if there's anybody in here who wants to use my StatLab, because it has an electronic version of the textbook, you'll need a course ID. All you have to do is email me. I'll give you that course ID. So that's for a student who, they're just a my StatLab, my math lab lover. They love it. They're like, can I get the course ID? I want to use it. Because it has an electronic version of the textbook. All right, here it is. Number 14. What kind of sampling method is this? A member of Congress wishes to determine her constituency's opinion regarding estate taxes. She divides her constituency into 3 income classes: low income households, middle income households, and upper income households. She then takes a simple random sample of households from each income class. What do you all think? I'm going to go to you, Tia. Yeah, she goes stratified. These groups, it was what? Low income, middle income, upper. Now you might disagree with that. Like, how are you defining middle income, right? But we're talking about stratified sampling. True, they were different groups. Something in common in each one of these homogeneous groups. Very good. Well, I already did one like 13, so I won't do that. Hey, how about number 17? A farmer divides his orchid into 50 subsections, randomly selects 4 of them, and then samples all the trees within the 4 subsections to approximate the yield of his orchid. What do you think? Cluster? You too? I already saw hands going up. Very good, cluster. So that was problem number 17. So 14, stratified. I'll put strat. Number 17, that was cluster sampling. Man, you're good. And I'm looking at the clock. And when we did great job, we got up from 1.1 to 1.4. Next class, we'll start 1.5. Safe travels this weekend. Stay safe. All right. If you have questions, stick around. Get it? Just that 5 minutes will save you.